you will see anywhere at the show, because first of all, you're listening to a diamond tweeter and a diamond mid-range, okay? And of course, human hearing is most sensitive to mid-range frequencies because that's where the human voice resides. And also, mid-range frequencies represent a very complex waveform, right? So all conventional cone materials, like paper, carbon fiber, polypropylene, whatever it is, they all will flex and bend at certain frequencies, right? So you, and so what's happening is the cone is adding its own sound. It's adding a coloration that isn't part of the signal supplied by your electronics, simply not in the recording. So some people say, well, I like paper cones, right? Well, what they mean is they just like the coloration, that euphonic, because the coloration, distortion doesn't always have to be unpleasant. Distortion can be pleasant. So this is a pure diamond cone. It's not diamond coated. It's actually a single piece of diamond, which behaves like a theoretically ideal piston. It will not flex or bend any frequencies. You will, for the first time, hear what the system is doing. So that distortion is completely eliminated. And of course, there's everything about this loudspeaker. First of all, the material here is a completely different alloy. It's not aluminum. It's about 5 times denser and stiffer than aluminum. And of course, this makes a huge difference. First of all, one of the problems with aluminum is that even though it's very stiff, which is good for low frequencies, it has, if you were to take an aluminum panel, even a thick one, and strike it with your knuckle, you hear ringing. It rings like a bell. So this is definitely, it's great for low frequencies, certainly not ideal for mid-range frequencies. This is completely eliminated in this design. And this is this is a 3-dimensional shape, and we carve it out of a single block. You can see machine lines in here. It's carved out of a single block of metal into this 3-dimensional shape, which helps to control diffraction effects. Because what happens is sound has spherical radiation, so it radiates in all directions, including it travels along the front baffle itself. So if you have a wide speaker, conventional shape, it's traveling along the baffle, and then it reflects from that baffle. In a fraction of a second later, it hits your ear with the original wave launch, creating smear, right? So it takes away, and you can immediately tell, because of that reflected energy, you can immediately tell where the speaker is. And there's 2 ways to control diffraction. One is to scatter it, and the other is to absorb it. So what we've done in this design is this shape helps to scatter this energy, and it's also narrow. The fact that it's narrow is good. And also we machine these inlays, which are made out of pure merino wool, which help absorb some of it. So you have both absorption and scattering. So when properly set up, and you really can't tell. If you close your eyes, you can't tell where the speakers are. You can't tell where the sound source is. And so we've worked very hard to eliminate all types of distortion: mechanical, acoustical, electric. Even the feet are made out of 904L steel, which is the same material that Rolexes are stamped from. So it's a lot of very exotic materials here. It's a unique alignment because of the way that, even though it's a vented cabinet, the roll-off is like that of a closed box, because closed boxes roll off at 12 dB per octave, vented boxes roll off at 24. And so even though we have a port in the back, the port is contributing much due to the strategic positioning of some materials inside. The port is contributing a lot less to the output than it would in the normal vented box. Other things which are also very important is that, in loudspeaker design, you have this, it gets complex when you're trying to balance one variable against the other. So on one hand, you want steep filters because they create better integration between drivers, better horizontal behavior, dispersion is better. The problem is that with more steeper filters, you need more parts to achieve them. So a 4th order filter has twice as many parts as a 2nd order filter, so then you achieve the steep roll-off, but you need twice as many parts. So even if you're using the best parts in the world, Teflon, film capacitors, or whatever, the signal has to travel through all those parts, and you lose that purity, which is not something you can measure, but you can definitely hear it. So we accomplish 4th order filters using basically computer simulation and working with the driver's natural transfer function to achieve a 48 dB per octave roll-off using so basically structurally it looks like a 2nd order filter, but it behaves electrically like a 4th order filter. So the driver is tricked into thinking that it's basically connected to a 4th order filter, so we minimize the parts count. And even though that it's minimized, the parts that we use are by far the best in the world, because all of the inductors in the loudspeaker are made with pure silver wire and cotton insulation. So what's the point of people go out and buy $5,000 speaker cables, completely oblivious to the fact that you have an inductor with 200 feet of wire in it, which is a magnet wire, just not even, it's just like low-grade copper with varnish insulation on it, and the signal has to travel through all that wire. So then why are you spending, and then somehow the speaker cable is going to fix the 200 feet of wire in front of it? I mean, so here you have absolutely pure laboratory-grade silver in cotton, which, by the way, has also the best dielectric constant, even better than Teflon, because Teflon is at 2 and cotton is at 1.5, so it's the closest thing we have to air in an inductor. So basically you end up with a presentation where the high frequencies are like they just don't have an electronic signature. What you're going to hear is that there's no like softness or hardness or brightness, all these sort of the audiophile metrics, they just don't apply. The way that people describe, oh, that speaker is bright and that speaker, they're just describing different types of distortions and colorations, but we've just taken them out altogether. So this is just kind of a brief overview of the design. There's a lot more, but right?
That's really good. And sitting and listening just a moment ago, it separates the voices very well. And Stevie Nicks is singing, and there's no edge or anything about the voice except the essence of Stevie Nicks. So you're getting a very natural presentation. I felt that the speaker sounded, with one word, correct.
Well, I think that what we see a lot in the industry in general is that a lot of people approach loudspeaker design and manufacturing like musical instruments.
Yeah.
But loudspeakers are the exact opposite of musical instruments. And so we don't design these products like musicians because, for example, we have we sold a pair of these loudspeakers. George Walker, who's a Pulitzer Prize winning composer and pianist. So how could my hearing ever come close to his? So how can I design with my ear? I cannot. And in fact, if you approach loudspeakers as some sort of musical instrument, the job of a loudspeaker is to actually, because an instrument, you want it to have resonant characteristics, you want it to have a character of its own, you want it to have a personality. The loudspeaker, you do the exact opposite. You want it to not have any character of its own. You don't want it to add anything to the signal. You want it to simply, faithfully reproduce exactly what's coming into it. And the more you do that, the more emotional experiences it creates. There's a direct correlation between doing that, eliminating distortion, and creating accuracy. There's a definite relationship. The more that so every time we eliminate some distortion, we eliminate some part that removes these artifacts, you get closer to the music, you get a more emotional response. And that, of course, also makes the loudspeaker, because it's just a pure transducer, a device that kind of just reproduces exactly what's coming into it. It becomes then, it could sound drastically different with different components. So if we were to bring in another set of amplifiers here, or another D-Wave converter, another set of key, it would just immediately change. You would just hear something completely different, because you may not be able to hear these differences in conventional equipment, because it's just not resolving enough. So due to the high resolution, it's very audible. So I think that's the correct approach to speaker design. Is just you're engineering something that, and another thing is also I think is unique in loudspeakers, that unlike electronics, where total distortion product is well below 1% in amplifiers and CD players or whatever. And loudspeakers, often you see distortion figures of 10%, sometimes more. So there's a lot more to be accomplished in loudspeaker design, which is why it probably has such a significant impact in the system.
Good.
So we're getting that way lower.
Good. Well, thank you very much. It's an excellent walkthrough of your new product, and I want to welcome you to the high-performance audio industry with a stellar introduction. It's superb.
Thanks so much.
Good. Thank you.
Look at all the lonely people. Look at all the lonely people. And in a repeat picks up the rice in the church where a wedding is window, wearing the face that she keeps in a jar by the door. Who is it for? All the lonely people. Where do they all come from? All the lonely people. Where do they all belong? Father Mackenzie, writing the words of a sermon that no one will hear. No one comes near. Look at him working down in the socks in the night when there's nobody there. What does he care? All the lonely people. Where do they all come from? All the lonely people. Where do they all belong? Ah, look at all the lonely people. Ah, look at all the lonely people. Ellen Rigby died in the church and was buried along with her name. Nobody came. Father Mackenzie wiping the dirt from his hands as he walks from the grave. No one was saved. Oh, the lonely people. Where do they all come from? Oh, the lonely people. Where do they all belong? Oh, the lonely people. Where do they all come from? Oh, the lonely people. Where do they all belong?
Outstanding, just outstanding. This is going to be a gold show winner. Fantastic.
You know what's really interesting is that we have the same track on the server
Oh,
at the same resolution,
mhm.
and it sounds completely different.
How about that? I'll be darned.
I don't understand. It's like ones and zeros, right?
Yeah, that's right. Yeah.
It's like, no, here it's like warmer, a little more, and that one seems a little more kind of more forward
Mhm.
and like more analytical sounding, but
Hmm.
it's very strange.
That is.
It's just a different source. I guess when you get to this like level of resolution in the system, you just like every little thing.
You can
is
hear
audible.
everything.
Yeah, like we move
Everything.
it a quarter of an inch, or like the power in a hotel fluctuates, and we get a different sound. It's just weird.
Mhm. Well, congratulations on a great, great speaker. Fantastic.
Thank you.
Thank you.